Hello, mathematicians. This is Ms. Backfish, and I am here to talk about synthetic division. I'm covering this up because this is not synthetic division. This is long division, and I just made a video about long division, and you are probably, if you're working on synthetic division, you probably have also worked on long division recently. But this was long division. Synthetic division is different from this. So what I want to do is I want to do this same problem in synthetic division. Now, let me point out to you that synthetic division, how to set it up, and at first how to set it up will seem a little weird, but how to get this set up is pretty much everything. This is what makes or breaks a synthetic division problem. First thing to point out here is we usually only do synthetic division when our divisor is variable plus or minus a number. X plus 5, A minus 3, Z plus 2. Just plus or minus a number. Variable to the first power. Not squared, not cubed, not anything else. Now, it can be done. You can do synthetic division when it's not like that. Most of the time, however, that's when we choose to do synthetic division. And I'll address how you could do it when it's not like that, when your divisor is different from that, at the end of this video. For now, let's just assume we're only going to do synthetic division with divisors that are variable plus or minus number, variable to the first power. Okay? So when we have this, if we're dividing by x plus 5, what I want to do first is I want to think about what root would go with that factor. Okay? In other words, if I knew that at the end of a problem I had factored out, some polynomial, let's say I had a quadratic and I factored it out, and I was trying to solve by factoring, remember that you take each factor and you set it equal to 0 and then solve, and that tells you the root that is associated with that factor. So negative 5 is the root or the 0 that is associated with the factor x plus 5. That's what I'm going to use to start here. I'm going to say, okay, the root that I would have if x plus 5 is a factor of x cubed plus x squared minus 19x plus 5, then the root would be negative 5. So I'm going to start out with a negative 5. I'm going to draw a little box like that. And then I'm going to take the dividend, the big polynomial I'm dividing out of, and I'm going to write a row next to this of just the coefficients. Remember, coefficients are the numbers in front of the variables. So I've got 1, and then negative 19, and then 5. So just the numbers, not the exponents, just the numbers that are coefficients. So 1, 1, negative 19, 5. Okay, so that was all in a row. Then I'm going to leave room for another row of numbers, and I'm going to write a horizontal line. Okay, now I'm ready to start. Now, if all that seems kind of just abstract, well, that's because it is the first couple of times you see it. You have to learn how to set it up like that. And once you get the hang of setting it up, it's pretty quick. Now, the first step is to take that leading coefficient, the number that was in front of my first term, and bring it down. And then what I'm going to do is I'm going to do a sequence. And actually, first I'm going to try and get my dog to stop barking. Alright, back from the dog barking issue. I'm going to do the same sequence over and over again, like a cycle, just like I had cycles when I did long division. I'm going to multiply this number times the number that's here and put my result here. Think of it like a big backwards check mark. This times this goes here. Then, unlike long division, I'm going to add vertically. I'm going to add these two numbers. So, for instance, here I have negative 5 times 1 gives me negative 5. And then when I add, 1 plus negative 5 is negative 4. That's the whole cycle. Then I'm going to do it again. Negative 5 times negative 4 goes here, and then I add. So negative 5 times negative 4 is 20, and then I add. Remember, in long division, we always subtracted vertically. Here we're just adding. Add with whatever signs are there. So negative 19 plus 20 is 1. Then I do it again. Negative 5 times 1 goes here, and then I add. 5 plus negative 5 is 0. This last term is the remainder, so this tells me that x plus 5 is a factor of this polynomial. Okay, it goes with a remainder of 0. That means this, my divisor, is a factor of my dividend. All right, now let me just remind you of that sequence there, that cycle we did over again. This times this goes here and then add. This times this goes here and then add. This times this goes here and then add. So that's what we did over and over again. Now, looking at our final result here along the bottom, we have to know how to read that. I already told you that the number to the far right, that's the remainder. Okay? What about the other numbers? Well, going right to left, we've got the remainder, and then we start working our way up in terms of powers of x. This would be x to the 0, or the constant term. This would be x to the first. This would be x to the second. So in other words, this says 1x squared minus 4x plus 1 with a remainder of 0. So this is my answer. All right. One thing to help me keep track of, sometimes people have trouble with the whole what power of x goes with each of these. Sometimes you'll see a little vertical line here. But the remainder is set aside over here, and then this is x to the 0, x to the first, x to the second, and so on. Another thing to notice here, if I start out with a polynomial that has x cubed, and I'm going to divide out x to the first, or in other words, I'm going to take out one of those x's, then I'm going to be left with 2 x's. If I have x cubed, x times x times x, and I divide out an x, now I've got x squared. So that can help you kind of make sense of, did this, does it make sense? Does my answer make sense in terms of what power of x it starts with? If I start out with x cubed and take away an x, I should end up with x squared as my, or a degree 2 answer. All right. This actually, once you get used to it, gets pretty fast, and a lot of students much prefer this. The drawback is, like I said, we usually only use it when our divisor is like this. So, it's more like long division can be used anytime. Synthetics is only when it's like this. That's not entirely true. Again, I mentioned I'll talk about that at the end of the video, but a lot of teachers stick with only divisors that are just variable plus or minus a number. Let's see, what else did I want to say about this? Another thing to notice about this is it's kind of like we just took the x's out. It's like we took an eraser and removed them to some extent. We still have things lining up vertically. Okay? When we're adding and subtracting, we're adding like terms. Which means, if I had a whole here, if I said, let's suppose my original dividend was x cubed minus 19x plus 5. In other words, there was no x squared term to be found. I can't have that. I can't have this is x cubed and then this represents x to the first. I have to have a column for each power going down from my degree, from my biggest power of x. Okay, let's do one like that to see what I'm talking about here. Okay, this time we're being asked to divide the polynomial x cubed plus 5x squared minus 3, all of that by the polynomial or the binomial x minus 2, x plus 2. So remember, when we are starting, we look at this, the divisor, the thing we're dividing by, and we say what root would go with that, or what 0 would go with that factor. In other words, x plus 2 equals 0 when x is negative 2. So that would be the root associated with that factor, and that's what we start with up here. All right, now, we talked about just using the coefficients here, but as I just said, we have to have a spot, a place, a column for each power of x, starting with our biggest power and working the way down. So in other words, if we start with x cubed, I need to have a spot for x cubed, a spot for x squared, a spot for x to the first, and there's no x to the first term here. So instead, I think of this as x cubed plus 5x squared plus 0x's minus 3. I have to have a placeholder for the x's, the x to the first power. So going across here, when I set it up, I'm going to have to place that, or keep that space. 1, 5, 0, negative 3. It's just these numbers, the coefficients of each of the terms in order, including a 0 if I have to hold any spaces. Then I'm going to leave a room for another row of numbers and then have a horizontal line. And finally, I'm going to bring this number down to start. One thing to notice is a lot of problems have a 1 here, and so sometimes students think, oh, it always starts with 1 here. Not necessarily. You're bringing down whatever's here. Whatever the leading coefficient is, you're bringing it down. So if it were 4 here, then it would be a 4 here. Negative 2, now we're starting the process. Negative 2 times 1 goes here, remember, and then we add. So negative 2 times 1 is negative 2. Add gives me 3. Negative 2 times 3 gives me negative 6. Add gives me negative 6. Negative 2 times negative 6 is positive 12. Adding gives me 9. Now remember, the very last number here is the remainder. So this time I do have a remainder. Moving over from there, this is my x to the 0, or constant term. The next one's my x to the 1. Sometimes we just write it right in here. Then here's my x to the 2. So this is x squared plus 3x minus 6. And just like we do with long division, we can write our remainder as plus whatever the remainder is over what we were dividing by, the divisor. So over x plus 2. And that is one way to write my answer. Okay, now notice that this time, excuse me, notice that this time it didn't do what we think of as going evenly. We got a remainder, okay? So that tells me that x plus 2 is not a factor of this polynomial, okay? Another thing that tells me, if this is not a factor, then this is not a root. So that's one thing we're finding out here as we go through synthetic division. We're finding out, based on whether or not we get a 0 remainder, whether this is a factor and whether this number associated with that factor is a root or a 0. In this case, no. X plus 2 is not a factor and negative 2 is not a root because we did not get a 0 here. Although the last one we did, yes, x plus 5 is a factor and negative 5 is a root of that polynomial because we got a remainder of 0. So this can be used to test a root. You can use it to test. If somebody asked me, is negative 5 a root of this polynomial? I could do exactly what I did here and say, yes, it is, because I got a 0 here. If somebody asked me, is negative 2 a root of this polynomial, the dividend, I would do synthetic division exactly like I did and say, no, it's not, because I got a remainder that was not 0. All right, let's go ahead and do a couple more examples. Okay, so this is a good place to go ahead and test yourself and see if you know how to set it up. This whole structure we come up with in terms of putting the number over here and the row of numbers and then the line. Can you set that up for this particular problem? You might want to pause your video and try. I'm going to go ahead and do it now. And that is, if I'm dividing by x plus 3, the root associated with that factor would be negative 3. So that's what goes over here. Okay? This is always going to be the opposite of that number, assuming it's just variable plus or minus a number. Okay, and then we have our row of numbers that are coefficients of the various terms in my polynomial. So 2, negative 5, negative 1, and 3. Those numbers just came from here. Then I have a space for another row of numbers and a horizontal line, and I go ahead and get ready to start by bringing down the first number. Notice this time it wasn't a 1. You bring down whatever the leading coefficient of the dividend is. So now I'm going to multiply. If you want to, go ahead and pause here and try to do the rest of the synthetic division and see if you get what you get, and see if you know how to write your answer. I'm going to go ahead and do it now. Negative 3 times 2 is negative 6. Then I add. Negative 3 times negative 11 is 33. Then I add. Negative 3 times 32 is, goodness, I didn't realize it was going to get this big today. That's going to be negative 96, right? Yeah. And then I add, and I get negative 93. So I just found out, based on the fact that this number is not 0, I found out that, first of all, I have a remainder. My remainder is negative 93. X plus 3 is not a factor of this polynomial up here. And negative 3 is not a root of this polynomial. Okay? So now I just have to think about how to write my answer. This is the remainder. This is the constant term, or like x to the 0. This is x to the first. This is x to the second. So 2x squared minus 11x plus 32 plus negative 93 over what I was dividing by, the divisor. And that is my answer. Okay, a couple things to notice again. Remember, I was dividing an x cubed by an x to the first, so I should expect my answer to have a reduced. In other words, I went from x cubed, I take one x out, now it's x squared. So that makes sense. Another thing I want to point out to you here is that in addition to being able to tell now that x plus 3 is not a factor of this polynomial and negative 3 is not a root, another thing that sometimes we use synthetic division for is if you think of this as a function. Let me go ahead and write it like that. If I said, here is the function 2x cubed minus 5x squared minus x plus 3, I want you to find f of negative 3. In other words, I want you to plug in negative 3 and see what you get. Turns out, this is what you get. Doing synthetic division is the same as plugging in that number into the dividend. Whatever the root is, it's the same as plugging in that number that your root is. So my answer is negative 93. So it can be a shortcut way of plugging in a number, finding a value of a function, evaluating a function for a particular number. Let's do another example. All right, here we go. Synthetic division. The root associated with this particular factor, or the one that's the divisor, would be positive 3. Then my coefficients, I don't have any holes. X to the third, x to the second, x to the first, x to the 0. I don't have to put a placeholder in. Always check for that. 1, 6, negative 21, negative 18. Leave space for another row of numbers and draw your line. Then bring down the leading coefficient, which just happens to be a 1, and remember it's not always going to be a 1. Then I'm going to start my process. This times this goes here, and I add. 3 times 1 makes 3, and I add. 3 times 9 makes 27, and I add. 3 times 6 makes 18, and I add. So this time my remainder is 0. What does that tell me? Well, it tells me x minus 3 is a factor of this polynomial. So that's another way this problem could have been phrased. It could have been find out or determine whether x minus 3 is a factor of the polynomial x cubed plus blah, 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 blah. Because this is 0, I found out that yes, it is. Another thing I found out is I found that positive 3 is a root. So if somebody asked me, find out, determine whether 3 is a root of this polynomial, I could do the exact same process I just did and say, yes, it is, because I got 0 for my remainder. Finally, I also could have been told, hey, this is my function. I want you to evaluate it for 3. Find out what the value of this function is when x is 3. Boom, 0. I just did that. So lots of different ways that your question can be phrased that lead to synthetic division being a good choice. So here's my remainder of 0. That means this is the constant term, the x to the 0 term, x to the 1, x to the 2. So my answer here is x squared plus 9x plus 6. Notice, by the way, that when I said, and I mentioned this in the last one, and I just kind of said it again, if I had this written as a function, and I said I want you to evaluate it when x is 3. I could do that exact same process, and I would say, oh, my answer is 0. That's called the remainder theorem. It is basically saying that this remainder is the same thing you're going to get if you plug in this number into that polynomial. All right, last thing I want to leave you with here, and this is, I think, less common, but let's suppose that I wanted to do synthetic division, and it was not set up this way, this x, or whatever your variable is, minus some number, or plus some number. You could think of it as minus a negative, plus a negative, whatever. Let's say, let me come up with a good problem here. Hang on one second. All right, here's an example of a problem. It's division, and my divisor is not just variable plus number or variable minus number. I've got a coefficient in front of my variable. All right? When I set up synthetic division, what goes in this place over here, and I'm going to go ahead and write these numbers so you know where this is coming from. What goes in this spot right here is the root associated with your divisor. So if you wanted to, you could take a divisor that is not just variable plus number or variable minus number, and you could say, what root is associated with this divisor? Well, that would be negative 1/2. And you could put that here, and now you can do this problem by synthetic division. I think it's probably pretty clear why we don't do that as often, is because we don't like to work with fractions to that extent if we can avoid doing so, just because we're more likely to make a mistake there. But in general, that's the most convenient time to do synthetic division, is when you're dividing by just x plus a number, x minus a number, etc. And I think I am like a lot of other teachers that would probably advise you, if it's not like that, go ahead and try long division. Hope this has helped, and I'll see you later.